What's poppin', dogs? Mr. Allen here, solving a few different exponential equations in this video. Now, we are starting pretty basic with the first example and then working to something quite advanced at the end. But all three of these examples are going to require the use of a calculator, so make sure you guys have yours handy. All right, let's get it started with the first one. I've got 5 to the x minus 6 equals 22. Now, what's unique about an exponential equation is that my variable is in the exponent, right? It's not like any other equation you may have encountered prior. But the process here is basically I got to get the base to the exponent on its own first. Okay, so that's our first algebraic goal, if you will. And then we'll get to the next part. So I'm going to add 6 to both sides as I normally would. And now I have 5 to the x equals, looks like what, 28? Cool. But now I have this x to my exponent. So what do? I can't divide by 5 on both sides. That's not how it works. It's 5 raised to the x, not 5 times x. Well, what we can do is we can rewrite this in logarithmic form. You see, logs allow us to solve for exponents because the answer to a logarithm is an exponent. So what I do is I loop it and I swoop it. That's a little bit of a bent swoop there, but that's okay. And what that does here is helps me organize my logarithm, okay? The first number is the base. Whether it's the base of the exponential equation or the logarithmic equation, it is always the base, which is nice. It's convenient, right? Consistency. So I got log base 5 of 28. That's the second number I passed by on my loop and the swoop, and then it ends on the x, so that equals x, all right? And now what I can do, I can just plug this into my calculator. That is it, okay? Now here is how you do it, okay? There's a few different ways to access this menu. This is my favorite because it's only 3 steps. Math, then the alpha button right above the math button, and then math again, and boom, up pops that log any base. If you don't have that, let me know in the comments. I'll help you guys work through that. I got a few different tutorials on it, all right? So we got a 5, arrow over, got a 28, hit enter, boom, I've got 2.0704. Let's go 3 decimal places, or in this case, 2 because the 0 is going to stay. X is approximately 2.07. It would be 04, so that works, okay? Now, I said approximately because we are rounding this value, right? So if I plug this in, let's plug it in and check our work. That's usually good practice in math. If I do 5 to the 2.07 and then minus 6, I should get very close to 22, right? 21.981 and change. Now, if I were to have done 5 raised and I grab this guy, did you know you could do that? You can arrow up and highlight, hit enter. It will copy and paste it down. You don't have to type the whole thing. Kind of awesome. Minus 6. I end up getting 21.999. I get 22, right? The calculator also rounds. It only rounds once. Very, very far off. We rounded once at the end, but you don't want to round throughout the problem given the opportunity that you have, okay? So always wait till the very end to round. We only had one opportunity here, but some of these other ones, there could be multiple places. All right, that's the first one, most basic, really one step, write it in log form, poof, there's our answer. This one's got a little more to it. This one's even crazy. If you guys can stick around for this one and you can handle this one, you're set, man. You're set. This is really as challenging as it gets right there. Okay, so let's do this next one. I have 4 times 1/2 to the x plus 6 equals 20. Okay, so it is tempting to do 4 times 1/2 and make it 2 to the x plus 6, but that is not allowed because this base is raised to an exponent. Exponents take priority, PEMDAS, order of operations, right? Please excuse my dear Aunt Sally. Exponents take priority over that multiplication. So we're going to solve for my exponent, okay? But the way we do that is I got to isolate the base with its exponent on its own side so that I can write it in log form. Okay? Cool. So what I'm going to do first here is I'm actually going to divide by 4 on both sides because I was multiplying by 4. It was 4 times that stuff. To undo it, I divide. And now we have 1/2 raised to the x plus 6 equals 5. Cool. No calculator needed yet, which is great. Okay. Next thing. Got to rewrite it in log form because I've gotten to the point where I have a base to an exponent. There's nothing else I can do. I can't divide by 1/2 on both sides. It's a base of an exponent. The way we do this is we rewrite it in log form. Anytime you're stuck in exponential form, try writing it in log form. If you're dealing with logs and you're stuck, try writing it in exponential form. Sometimes you can go back and forth and it helps you solve the problem. I got videos on both, so be sure to check those out. This is probably part of that playlist, so just keep on watching, keep on mathing. You know you want to keep on mathing. All right. We got base 1/2 here, and then we have of 5, because that's the next number I pass by, right? The base is always the base. I pass by the argument of the log, and the log equals the exponent, which is x plus 6. All right. Now, let's go ahead and almost finished solving this. Math, alpha, math. I've got 0.5 or 1/2. Then we got 5. Hit enter. Is that my answer? No. I am going to subtract 6 on both sides. And let's show our steps here because, math teachers, they love steps, right? They love steps. So I got negative 2.321 and change. And I know that would round 321. I usually put a dot, dot, dot when I'm still mathing. And then I'll subtract 6 on both sides. And we're going to get x equals, and I'm going to put this in a different color because I'm going to try to fit this in here and not get in the way of my calculator. X equals approximately negative 8.3219, so 322. Negative 8.322. Boom. There is my final answer. Nice. I think a lot of teachers will actually allow you to just skip this step. It is helpful to write that down so they also know, like, oh, you knew the decimal. Like, if you made some dumb mistake, you accidentally added 6 instead of subtracted, at least they see that you did this correct, and then you show your other algebraic mistakes. A lot of times you'll get, like, only a half point off or something like that. So it is beneficial to show your mistake, even though it takes a little bit of time to write it down. Plus, if you're, like, taking a quiz and you're looking back, and you're like, hey, where did I go wrong? And you have nothing written down. You don't remember what you did, right? It helps to have it actually written down, and you'll see your mistake, and then be able to learn from your mistake. Okay, there we go, guys. Enough about mistakes. We got 2 answers. On to the big dog at the end here. We got a lot. Okay, and I left a little extra room for this one, so let's get after it right now. I'm going to go with, we'll go with orange on this one. So our goal is to get to the thing that is raised to a power, our base raised to a power, not our thing raised to a power. All right, let's use proper terms here. So the 4 raised to the 3x minus 1, we want to isolate that first. Do I divide by 2 or do I subtract 5? If you said subtract 5, you are absolutely correct. So we're going to have 2 times 4 to the 3x minus 1 equals, if I subtract 5, what is that, 16? It sure is. That was a weird short one compared to the 16, so I had to fix it. Now, let's divide by 2 on both sides, and I'm running short on room, so I'm not going to show the division, but you know it's there, all right? All right, divide by 2, I get 8. There we go. If you want, I could, minus 5, really tiny. Minus 5. Divide by 2. Whee! Divide by 2. Yeah. Okay. Now I have the base raised to an exponent equals the number. We can rewrite this in log form. So base of 4, log base 4 of 8 equals 3x minus 1. Let's jot that down. We're going to go all the way up here. That is, I don't know how I forgot to draw an arrow. That is an arrow, folks. That is an arrow. Okay. We have log base 4 of 8 equals 3x minus 1. Okay, so now what I like to do is I'm going to leave everything in the calculator as I do this algebra, okay? So we'll hit math alpha math, math alpha math. I'll type in the 4, type in the 8, get a decimal, 1.5. That's not bad, right? There would be a way to do that one by hand. We're not going to get into that here because these types of problems, we're going to have a calculator. All right. Here you could have possibly, this could have been a non-calc actually. We could have made this a 2 to the second power and a 2 to the third power and done our 1-to-1 property of exponents. But just kind of worked out that way very nicely when I randomly made this problem. But we'll continue going with the calculator here. So now what I got is I'm going to have to add 1 to both sides. So we end up with, let's see here, we got 1.5. Equals 3x minus 1. Add the 1, we get 2.5. And then we'll divide by 3, and we'll get x equals 2.5 divided by 3. That'd be easier if it was all, an improper fraction. 0.83 repeating. Check this out. If your teacher wants a fraction, hit math, enter on frac, and boom, we get 5/6. Okay. So 5/6 is my final answer. Yes, again, this could have shown up, even something as crazy as this, on a non-calc just by chance of how I made the numbers, but that would be the process going through basically for any situation. If say I had 23 over here to start with, that was 18, now it's a 9, now it's a huge mess. So, hope that helps you guys. That's a lot right there, solving for missing exponents, especially when you have expressions up in your exponent. There's additional steps to do after you put it into log form. You got to do a little bit more algebra. So make sure you guys are keeping those decimals in your calculator, because if you start rounding along the way, your answer is going to be slightly off, more often in certain situations than other situations. But just to be safe, only round once for mathematical accuracy at the very end of your problem. All right. If you guys have any questions or any calculator issues, pop in the comments. I'm happy to help. Otherwise, Have a dope day.